Hello, I am really excited to be here. I am a Salem resident of 9 years. I've been working in the energy efficiency space for over 20 years, and most recently, I serve as deputy director at a Boston-based nonprofit called Browning the Green Space. And Browning the Green Space, we call it BGS for short, is focused on advancing diversity, equity, and inclusion in clean energy and climate tech with our threefold mission to create jobs, build wealth, and reduce the energy burden in communities of color across New England as we seek to simultaneously close the racial wealth gap and address climate change. And a lot of what we focus on is workforce development and supply chain opportunities around the nascent offshore wind sector here in Massachusetts. And looking forward to this conversation with Eric and Matt around what offshore wind is going to bring to Salem and what it means. So why are we even talking about offshore wind? Because of climate change. I think we all know that the earth is getting warmer. We see the floods, the hurricanes, the fires, the droughts, the record temperatures. But I think what some people aren't aware is that climate change, while it affects everyone, it doesn't affect everyone in the same way. And what we call environmental justice communities are most vulnerable to the impacts of climate change. Environmental justice communities are defined at the federal level, at the Massachusetts level. In general, they all meet some similar requirements associated with communities of color, low-income communities, communities that have a high percentage of non-white residents and immigrant populations. And so when we talk about environmental justice communities, those are the communities that we talk about that are more vulnerable. And Browning the Green Space focuses on elevating their voices in the work to mitigate climate change. So why offshore wind? In order to have any chance at mitigating the impacts of climate change, we need to reduce how much gas, oil, and coal we're burning. And to do that, we need to replace those sources of fuel. So Massachusetts has identified the most cost-effective and equitable strategies to reduce our consumption of oil and gas and replace it with electricity. And you can see in this chart here, right now, most of our electricity is produced by burning gas. By 2050, the hope is for the majority of our electricity to come from wind electricity generation, with also some solar and a small amount of gas. Why wind? Because here in Massachusetts, we are very fortunate to have abundant wind resources right off the coast. It's some of the best wind that's available in the country and is the most reliable, the most consistent, and potentially the most equitable. So that's why we're talking about it here. How does wind work? We've got a video here. As I was pulling together some of the material for this event today, my 8-year-old came over and was looking over my shoulder as I had a picture of an offshore wind turbine on my screen, and he said, "Wow, you could have one of those in the water?" And I was kind of embarrassed because for all the talk about wind turbines and offshore wind, I realized that sometimes you make a sound and you don't realize that other people are just hearing a sound. They're not connecting what those words mean. So I won't make you raise your hand if you didn't realize that offshore wind turbines are actually constructed in the water, but to get us all on the same page, I'm going to show this video from the Business Network for Offshore Wind, kind of a little overview of what wind turbines do and what offshore wind is.
Every 24 hours, wind generates enough kinetic energy to produce roughly 35 times more electricity than humanity uses each day. And unlike coal or oil, this resource is totally renewed each day. So how can we harness this incredible amount of energy? And is it possible to create a world powered entirely by wind? The basic principle of wind energy is simple. A series of sails or blades mounted around a rotor catch the wind and translate its kinetic energy into rotational energy. Traditional windmills use that rotational energy to grind wheat or pump water. But in modern wind turbines, it turns a generator that creates electricity. This conversion from wind to rotational energy to electricity has defined wind turbines since their invention in the late 19th century. And there are three primary factors that determine just how much energy they can produce: the size and orientation of the blades aerodynamic design, and the amount of wind turning the rotor. First up, blade orientation. Wind turbines can be designed with their rotor on a vertical axis or a horizontal axis. Vertical blades can pick up wind coming from any direction, but with much less efficiency than horizontal axis rotors. Horizontal designs allow blades to capture the wind's full force by tracking the wind's direction and turning to face it. This turning process is called yawing, and older windmills achieved it through manual monitoring. Today, wind sensors and computer systems automatically adjust the blades with expert precision to capture as much energy as possible. Outside rotor orientation, the blades themselves need to be shaped to maximize efficiency. While early designs used flat blades, modern blades are curved like airplane wings. Wind travels faster over the curved surface, creating a low-pressure pocket above the blade that forces it upwards. Since the amount of lift depends on the angle at which the wind is moving relative to the blade, modern blades also incorporate a twist, optimizing how much of the blade can cut into the wind. Made of fiberglass and resin layers, these blades are strong enough to operate through rain, lightning, and blistering sunlight for over 20 years. Even with aerodynamic blades and a horizontal rotor, a wind turbine can only capture wind if it's in a windy environment. Wind speeds typically increase the higher into the atmosphere you travel. So today, most turbines are well over 100 meters tall, with equally large rotor diameters. A turbine of this height and size can capture a huge amount of wind, generating enough electricity every year to power 750 American homes. A wind farm of 200 similarly sized turbines could power over 150,000 American homes, or twice as many European homes, for an entire year. Offshore wind farms contain an even greater number of even larger turbines. In 2019, the largest wind turbine ever built began operating off the coast of the Netherlands. With a rotor diameter of 220 meters, just one of these turbines can meet the annual power needs of 16,000 European households. Despite its amazing potential, wind energy still faces challenges. Wind may be a free and unlimited fuel, but no matter how large or efficient a turbine is, there's a mathematical limit to how much wind it can convert into electricity. German physicist Albert Betz calculated that since some wind must remain to keep the blades spinning, a turbine can only ever capture 59.3% of the wind's energy. Additionally, some people feel turbines disrupt natural scenery, and wind energy's intermittent availability can make it difficult to integrate into electrical grids. But even with these challenges, modern wind turbines have made wind energy the most efficient and inexpensive source of electricity. Wind turbines already provide essential energy for communities around the world, and for many farmers, hosting a wind turbine can be a reliable source of additional income. With continued improvements in wind forecasting, electrical grid infrastructure, and energy storage, wind power might blow away all our energy problems. Next up, learn how solar energy works. Or, if you're more of a big picture person, explore whether we could power our world with 100% renewable energy.
So I talked a little bit about, what is offshore wind, and Eric's here and Matt's here to talk more deeply about what it is. But we're also going to talk about why Salem. And Salem is a very unique and special to the offshore wind industry because of the Salem Harbor. What you see here is the sea installer that some of you may have seen come to port a couple of weeks ago for inspection. And why was it here when it was going over to the other side of the Cape and Martha's Vineyard? Because it fit. That's really the reason. It fit here. It didn't fit in New Bedford. And qualities like that around the nature of the port is what makes Salem so valuable for this new offshore wind industry. And I'll leave it to Eric and Matt to talk in more detail about why that is. But as a Salem resident, I wanted to share a different perspective. Salem is a gateway city, and much like environmental justice communities, gateway city is defined within Massachusetts as cities having certain parameters, mid-sized urban centers. They have a history of economic prosperity, but in recent years, their legacy of economic success has shifted as the economy shifted to a skills-based economy. In Salem many years ago, the economy prospered around tanneries, and those are long gone. In this picture here on the top right is a soccer field in Gallows Hill Park, right by where I live. A couple of years ago, arsenic was found in the field when they went to renovate the field. Arsenic is a byproduct of the tannery industry, and this is from just last week. I went over there and took this picture. They're still in the process of renovating this field. It took a long time, from what I understand, to get enough funding. I don't know if we even have enough funding to remediate all the arsenic that was there. And in the background of this picture, you see Salem Heights, which recently underwent some renovations also to improve the energy efficiency. They got heat pumps, they got solar panels, but also it's experiencing tragedies as it did this weekend on a regular basis. So this is really a pivot point for the city where we can leverage the untapped resources that we have while still being mindful of the environmental impact that new industries can have on the city. When the sea installer was in port, some of the residents that live around Derby Street were complaining about the fumes. One resident of Derby Street said that he had to keep his inhaler close by so that it didn't trigger his asthma attack. So no industry is without environmental impact, but the offshore wind industry also has a lot of opportunities. So I really want this to be an open conversation about what opportunities offshore wind presents and what challenges we should be prepared to address from the start. But when we talk about those opportunities, what are they? Green jobs can be blue-collar jobs and white-collar jobs. And not expecting you to read all of this, but what I do want to point out is that when you look at the length of each of the phases of the offshore wind process, the project development, the construction, the installation, the operations maintenance, that's a 20-year phase. So as we think about what opportunities will be available here in Salem for the long term that we can really plan for and build for, that O&M period is the one that's really going to be here to stay with us. So to set the stage before I hand it over to Eric and to Matt, solving the climate crisis means solving it for everyone, not just a select few. And unfortunately, the climate crisis impacts the communities that have historically been left out of economic opportunities that new technology can bring. So how can we as a region, as a city, ensure equitable access to the opportunities that this new sector brings, that the offshore wind industry can offer? And in Bright and Green Space, we've been working on this for a few years. Some of the insights that we've gleaned from our work in bringing equity to offshore wind, building relationships. That's really why we're here. Learn the history of the community, what's been promised before, and most importantly, be transparent about both the opportunities and the challenges and the risks. Policy. They say all politics is local. Let's build in metrics and accountability measures as a community and what the impacts are for our community. Transparency, as I've been talking about, address knowledge gaps. What are the opportunities that are available? I think that having just the fact that offshore wind is going to be in Salem is going to bring awareness to the sector and to renewable energy in general to populations that maybe this wouldn't have been on the radar at all. So let's leverage at minimum, even if those jobs aren't going to be created here locally, let's leverage this opportunity to bring awareness to the many opportunities that renewable energy can bring. Understand and remove barriers to entry. That's knowledge. Did you know wind turbines actually operate in the water? Financial, transportation, technology. Some people don't know how to swim. Is that a barrier? Can we provide swimming lessons? Network, social, et cetera. Focus on workforce development regionally. And how do we train now for something that's not here yet? By exploring transferable skills, understanding what jobs are union jobs, what's not a union job, and looking at the phases of each piece of the offshore wind industry, like that 20-year O&M phase of the sector. And most importantly, mitigating environmental harms, establish a process so that we can identify, when someone is having an asthma attack because of the fumes coming into their apartment. How are we going to acknowledge that? How are we going to track that? And how are we going to swiftly remediate that? At this point, I told you a little bit about who I am, Deputy Director at Brown and the Green Space. I am trained as a mechanical engineer, served my time as a mechanical engineer in the HVAC, construction management, and energy analysis space, and now work for BGS as Deputy Director. And I think I will hand it over to you, Eric, to do your own intro, because I don't think I could do it justice by just reading the slide.
Thank you, Hadas, and thank you, Bonnie, and Pat and Jim and everybody from SAFE for having me here tonight to talk about this. It's an exciting time, and I'm Eric Hines. I direct the Offshore Wind Graduate Program at Tufts University. We started the program in 2019 after several years of having been in the middle of some of these early projects in the offshore wind industry, and realizing that as an act of stewardship, we wanted to start a program to give our students a front row seats, and to give students in general a front row seat to this industry as it's unfolding in our backyards. It's not every day. In fact, it's not even every generation that something like this comes along, and we're in the middle of a convergence of a lot of historic scale events happening at the same time. We're retiring in the last several years a quarter of our electricity generation capacity in New England. What do we replace it with? We don't want to replace it with new fossil fuel generated plants. We are in the middle of, we're in a location in the world that has some of the best wind, as Hadas was saying. And we have a very dynamic environment, an incredible ground game in Massachusetts. Massachusetts has been at this for over 2 decades. And since 2016, when Massachusetts created this historic legislation for offshore wind, we have been at the cutting edge of this new industry. And so we're committed to making the industry understandable and available and present for our students, and we're committed to thinking about this at a systems level, because this isn't just about building new technology that suddenly solves the problem. This is really about all of our systems, our infrastructure, our supply chain, our transmission, and the people working together. And so all you have to do is start looking at the wind energy areas and start connecting them together with lines and start realizing where the transmission is going to go, and you can start to see who has to work together. So that's our work at Tufts. I'm very excited to talk about Salem and what's going on here. 10 years ago, we weren't imagining this would be where things are, and so this is a really nice moment to be here talking with you all.
And Matt is online.
I'll just give a quick introduction, then I think we go back to Eric. But so my name is Matt Shields. I work at the National Renewable Energy Lab. I just want to kind of echo what Eric said. Thanks so much for having me here today and being able to accommodate me dialing in virtually. We're based in Colorado as a lab. And NREL has been interested in offshore wind for 20 years now. I think we started by doing some of the first sort of fundamental science pictures of what offshore wind could look like, just even looking at the wind resource. And I think some of these statistics we've already heard today about, the quality of the wind resource in Massachusetts. I think that those are some of the original problems that interested NREL as a lab. And we spent a long time looking into some of the sort of the technical aspects of developing offshore wind. In the last 5+ years, though, it's become more and more apparent that just knowing how to improve the power generation of a wind turbine blade is not sufficient to really stand this industry up in the U.S. I mean, certainly that's a critical part of it, but we need to understand the supply chain and the infrastructure and the workforce and how these different infrastructure and societal and economic benefits intersect with the historic technology work that we had done at the lab. So we've been doing a lot of work in this since I think we published a first paper in 2016, which looked at how costs could vary over the entire U.S. space, and that's grown into this this program of looking into the supply chain and ports and vessels and things like that. And so we've been able to do some work in the last couple of years looking at really what it would mean to develop a supply chain for offshore wind in the U.S. and what's some of the value propositions for doing that. And I'm excited to be here to talk a little bit about that, kind of on the broad scale, and then how that links to what's happening in Salem and in the state of Massachusetts overall. So thanks again for having me here.
Thank you, Matt. And now we'll hand it over to Eric to talk us through some of his work.
Okay, thank you.
You want to drive?
Sure. So this is the Sea Installer. You all are more familiar with the ship than I am at this point. It arrived in the harbor, and I think what's notable is just how big it is. The scale of this is enormous, and I think hard to comprehend until someone encounters it in person. And this is what you all did. And as it sort of came into the harbor, watching, what is this thing and how many are there? And is this normal or is this something new? And then at the same time, it's also, creating a level of emissions that are causing local residents to respond, one with an asthma attack. And so what does this mean for our city? It's kind of hard to avoid this question at this point. And I think the question of what does this mean for our city and what do we want is a really important question for you all and for your fellow citizens to be asking right now, because what gets decided now is going to determine the course of the next several decades. So just to put this in context, you can see a ship that's a little around the same size, perhaps a little smaller than the Sea Installer, on the left installing one of the Block Island wind turbines. Just for context, that's a 6 megawatt turbine. The turbines being installed at the Vineyard Wind 1 site are now 13 megawatt turbines. That's not too many years later, and the growth in the size of the turbines has been exponential over the last several years. And so there are many things that have happened at the same time to bring us to this point. Another thing that happened was that the cost actually came down precipitously. So the Block Island cost of the power purchase agreement for Block Island was around $244 a megawatt hour. For Cape Wind back in the day before 2014, it was about $187. When Vineyard Wind came in 2018, in 2017 dollars, the Massachusetts Department of Energy Resources estimated that to be around $67 a megawatt hour. And so breaking this $100 a megawatt hour barrier was an incredible thing that no one expected. And at the same time, what I really want to draw your attention to is that on the left, that large ship, that's the European ship. On the right, that's the US ship. And we're not used to thinking about ourselves in that way. Really? That's the best we can do? We do not have large-scale what are called wind turbine installation vessels, or WTIVs, or people call them jack-up barges. You'll hear several different names for these. That's a feeder barge, and it's one of the larger feeder barges down in the Gulf of Mexico. Just because we have a thriving oil and gas industry, just because we have all of these things we can accomplish in the water, doesn't mean that we're prepared to install offshore wind. And so we've always known for over 10 years that these first few tranches, first few wind farms would be built based on imports. And so you'll hear more about this. And to the right, I just included some early sketches of ours where we were trying to figure out, a lot of this is proprietary knowledge, but we learned that a lot of this knowledge is also hiding in plain sight if you think about things in the right way. And I think that's another message, that a lot of the information that one needs and can learn about this industry can be found in publicly available information. But you can see that that was when I was trying to puzzle through and just sketch, well, how big is the Brave Tern, from Europe, and how big is the Robert and the Jill, and what are these? But I think this photo kind of says it all. And so this is where we are right now. And we can see this as it's a little humbling, and it also is a moment of opportunity. At the same time, in 2021, we were interested in this question, well, if we don't have that many of these vessels, how many are we going to need? And so we started to play with this question. We looked at the procurement schedules, we looked at the construction schedules. Again, all of this is publicly available data. And we determined that by about 2027, we thought the United States was going to need 5 of these vessels. Now that's tough, because at the same time, to our calculations, there were only 3 in the world, not just in the United States, in the world that could install a GE 12 or 13 megawatt turbine in 50 meters of water. So think about this. You have the water depth, you have the legs of the jackup vessel. Sometimes people call those the spuds. So how high and how deep can it jack up? You have the crane. How heavy can you lift something? And then how tall can you lift it? And so these are the parameters that matter, and you can't just write these down in a table. You kind of have to wind up drawing the whole vessel to sort of understand how it all fits together. And then you match this together, you say we need 5. Well, there were 4 more under construction in 2021. That's about 7. But now you've got offshore wind is exploding as a global industry phenomenon, and it's very difficult to book one of these vessels. So you might ask the question, well, how did Vineyard Wind actually book this vessel? And you can see this here. At the time in 2021, you can see we showed the future capable vessels, the 4 of them that were under construction, the existing capable in the green, and then the existing what we called incapable. And at the time, the sea installer was not ready to install these turbines. But you can also see the headline from the right was that the sea installer underwent a renovation. And so these vessels, which are very unique in the world at the global supply chain level, are being retrofitted with new cranes so that they can install these larger turbines. This is how quickly this industry is moving. Just for context, the Cape Wind turbines, 3.6 megawatts. The Vineyard Wind 1 turbines, 13 megawatts. That's almost 4 times bigger than Cape Wind. So this is what happened right in front of our very eyes in this historic moment, all of these historic scale phenomena happening. There is, that's the first turbine leaving New Bedford Harbor through the hurricane barrier. Hadas mentioned the hurricane barrier is width constrained. There are no height constraints. We don't, what we call overhead restrictions. There aren't bridges in New Bedford. New Bedford Harbor is protected. That was always seen as an asset to the terminal. But you have a very hard time fitting a vessel like the sea installer, if it even is possible, through the hurricane barrier, which is about 150 feet wide. And so what is transiting, that doesn't stop us from building a wind farm, because the wind turbine components are transited via what are called feeder barges. And so that's a feeder barge that you see being tugged with tugboats out to the Vineyard Wind Fund site. This just happened this last week. So again, we're in the middle of this historic moment. That is a picture also taken this summer of some of these initial turbine components being staged in New Bedford at the Marine Commerce Terminal. And you can see how tall they are, you can see the cranes, and you can imagine, my goodness, if we designed the Marine Commerce Terminal in 2011 to 2014 and we were contemplating 3.6 megawatt turbines, how can you even stage a 13 megawatt turbine out at this point? Well, we had the good fortune of having just come off of designing the Wind Technology Testing Center for Massachusetts, and we designed that for 90-meter blades, which also turns out is too short at this point. The GE blades for these turbines is 107 meters long. I remember asking the question, should we design this for 100-meter blades? And everybody in the room just laughed, in 2009. No way are we ever going to get there. I mean, that's way out, 2050, 30 years in the future. And here we are in 2023 with these large blades. And so, but we designed the terminal for an increased capacity to anticipate these large turbines and to anticipate these loads. And I would also say the loads that we're dealing with now are definitely on the high side, if not a little higher than what we anticipated, but we designed the terminal in such a way that as the loads became bigger, the terminal had a ruggedness to it and it was prepared. And so in choosing these initial designs, there was a lot of talk, as it was led by the Massachusetts Clean Energy Center, to design a terminal that had staying power and that was essentially trying to future-proof this terminal. There is an article written in 2017 by our team on the terminal. I encourage you to read it. You can download it off of the Tufts website. If you Google Tufts Offshore Wind, you go to our story, Marine Commerce Terminal, you can see this article and you can kind of get a sense of what it was. And everybody used to always joke, you know, how can anybody look, it basically looks like a big parking lot. Like, how can anybody look at that and sort of see the marvel of engineering that everybody was so proud of when we had finished the terminal? What you have to think about when you think about this terminal is you have to think, we're carrying some of the heaviest loads in the world, 10 to 20 times larger than the container cranes that you might see in South Boston or somewhere on the New Jersey Turnpike. We're building the terminal, we have to carry these very heavy loads on what's, you know, this quayside right there, the upland area, and we have to dredge a channel in what is a glacial moraine, which has very, a lot of boulders, a lot of bedrock, has little mountains of bedrock on the underneath. This all has to be blasted out. And at the same time, we're doing this in a contaminated harbor. This is one of the largest Superfund sites in the country, over 18,000 acres of contaminated from PCBs that were dumped in the harbor in the mid 20th century, during the time when there was capacitors being manufactured in that part of the world, and a very significant Superfund site. All of this comes together into this question about these gateway cities, the question of a new industry, and how do you build this? And so this is, fortunately, I think, Massachusetts has been through this, and we've known about this for a long time, and now Salem is really sort of the next big terminal that's being talked about. And in this time scale, 10 years is not that long. In some ways, it's a long time because we don't have a lot of time left to accomplish the energy transition, but on the level of infrastructure and kind of understanding how these things unfold, I think it's instructive to look at these other projects. And so when New Bedford was completed, it was completed in time to service Cape Wind. It wasn't built for Cape Wind, but it was completed in time at the end of 2014. And you all know the story. Cape Wind did not move forward. They lost part of their financing, then lost the power purchase agreement. And the next year, people really thought that offshore wind was over in New England, and there was this real problem. Leases sold for $1 an acre, approximately, at the end of January 2015. Fast forward to 2016, after Massachusetts passes the legislation. Does anybody know what the New York lease went for that year? Do you remember that? Yeah. It was the most recent one went for $1 billion. That was in 2022. In 2016, they went for $46 million or $42 million, about 150 times, around over $100 an acre. And then by 2018, the Massachusetts leases that didn't even sell at the end of 2015 went for $1,000 an acre. And this last round in the New York Bight, it's reached gold rush level, right? Where you're just like, this is too much going on. There was a lease that sold for $1 billion or $10,000 an acre. So again, my message to everybody here is that we are in this moment in time. It's a very hard moment to understand unless you zoom out far enough, and it's really important to pay attention not only to what's going on in one's own town, but what's going on in the state, in the region, and nationally. And it's an exciting conversation. And so as we think about what does the ecosystem look like, the New England offshore wind ecosystem is already very strong, and you can see here we've got municipalities, we've got Massachusetts assets that we've constructed, we've got points of interconnection, that's what the POI is, research and education, labor unions. This is a partial list, but if you look at New Bedford and you look at the proximity to the wind energy areas, you can see why New Bedford made sense as a first mover. It was right next to the wind energy areas. What's interesting is that Salem, on the other side of Cape Cod, actually became a real possibility to service these wind energy areas. This is how important Salem is. This is the kind of asset that Salem is. And these are the things that should lead one to question, well, why Salem? Why did we land in Salem? What are the other ports? What were the other options? And the fact is that the industry has settled on Salem as being the next major port in this part of the world. And so I want to talk about the North Shore now, because now that Salem is on the map, the entire North Shore is on the map. And if you look at the North Shore, there's a pin in Salem on the Google Earth image that you see here. And this is a thought experiment on offshore wind manufacturing. Salem has a port. Lynn has an existing GE manufacturing facility. The IUE-CWA came to me a couple of years ago and said, how could we think about this as a nacelle manufacturing facility? This was just a thought experiment. We were looking at channel depths. We were looking at, and you realize that Lynn is 20 nautical miles from Salem, 20 nautical miles from Everett, 20 nautical miles from Quincy. These components are so big, no city is going to manufacture all of them. And you could imagine Salem being a staging port where you actually barge components from Lynn over to Salem, where Everett is right across the river from the Wind Technology Testing Center that tests the wind turbine blades. People have been talking about Quincy as a port for a long time. It's natural to start to think about an entire ecosystem in the North Shore. We were looking at the bridges. Those are 2 bascule bridges in Lynn, and you see that there are overland routes in terms of getting from the GE facility to the port in Lynn. There's a very strong factory workforce, manufacturing workforce in Lynn. And what you see in Lynn, as you look at this, is that the channel is about 15 to 16 and a half feet wide and about 150 feet wide and about 15 to 16 and a half feet deep. And if you contrast this with Salem, Salem has a 300-foot wide channel that's 28 feet deep. And so this idea that Salem has this channel that is wide, it is deep, it is a deep water port by New England standards, and there are no overhead restrictions, there are no width restrictions. That already, if you just want to take a tour of the East Coast, anybody can do this on Google Earth. Just look at the coastline and look at sort of these different things that are in the way, and you start to realize that Salem is uniquely positioned. And the other message about Salem is that if you expand out and you take zoom out a little further on this ecosystem, you see those little wind energy areas on the bottom, and then you see this massive planting area in the Gulf of Maine. Those little wind energy areas are in somewhere between 30 to 60 meters of water. The Gulf of Maine is about 300 meters of water. That's floating offshore wind. As far as the United States is concerned, floating offshore wind is the future of offshore wind, not just in the United States, but also globally. And where is Salem? Salem is positioned right on the Gulf of Maine. So the way that I would think, if I were you all, is this is amazing. We actually get to cut our teeth with an offshore wind port in the context of these existing projects, and we are on the cutting edge, and we are perfectly positioned to lead going into the next several decades, first with the Gulf of Maine and then into floating offshore wind. And so as you think about this, again, it's not my business to answer the question, what do we want? What does all of this mean? But we would like to be helpful, both Matt and I, in terms of situating your context and your opportunity inside of this larger picture. It's a very compelling time, and as I mentioned earlier, the decisions that are made now are going to make an impact for decades to come.
Thank you, Eric. Before we switch over to Matt, I just want to kind of break it down in a little more of a relatable terminology. So when you talk about a gigawatt, how many houses does that power? How many cities? What does the gigawatt mean? And what are we looking to do here in the Northeast?
So a lot of times we talk about this in terms of powering homes. And I think that one way to think about that, and I can't do the calculation in my head right off the top. I'm not going to try to do that in front of everybody. But I will say this in terms of how I think about it. New England, the 6 New England states, we have about 30 gigawatts of electricity generation capacity. We use about half of that on any given day. You could say it's 32, we use 16, okay? But I'm just gonna use these round numbers. Imagine you have 30 gigawatts, we use about 15, we use about half on any given day. That's typical for electricity capacity. And in the last several years, we were retiring about 8 gigawatts, about a quarter of our electricity generation capacity. So as you think, we talk about gigawatt scale, the kinds of farms that we're building are at the utility scale that can actually power a percentage of all of New England. And the other thing I'd recommend is, I don't know if you want to pull out your phones, there's an app actually called ISO to Go, ISO to go. You can literally look it up. You can tap on ISO to go, and you can look and you can see exactly how much the power is being sold for right now. The wholesale cost of power in Boston at the hub is $34.40 a megawatt hour, and you can see the demand chart. And right now we're using literally 15 gigawatts of power, and you can see where we are in the evening, and you can look at this. And these are all very simple things to access that I recommend, because this is a language that we'll all begin to speak more of as we start to think about getting our power from these alternative sources.
So the numbers that you're talking about in terms of what's available off the coast of New England is more than enough to replace the amount of electricity that we're currently generating and using.
Absolutely. Thousands of homes.
Great. I'll hand it over to Matt now to talk about some of his work on a national context.
Yeah, thanks, Hadas. And I've got the advantage of being at my computer here, so I can look up some statistics quickly. And the number that we usually quote at NREL as the Department of Energy is in the order of like a 1 gigawatt project can power maybe 300,000 homes. So that's roughly the size of per offshore wind project which is being built in some of these East Coast lease areas. So yeah, when you add them all up, you're definitely talking about millions of homes that could be powered. So I think it's a really, really substantial resource. We're not talking about small scale projects here. But with that, I might just jump into my presentation here, so we have some time for questions at the end. I'm mostly going to be talking about some of the the broader industry context, and then a bit about what that means for the supply chain. So when we talk about offshore wind globally, this is a chart from one of our recent offshore wind market reports. By the end of 2022, we've installed about 59 gigawatts globally, and some of the leaders in that area are in China and Northern Europe. And you got to zoom way into the bottom to see the U.S. in that area. We've got 42 megawatts. That's 7 wind turbines installed in the U.S. So I think we've been pretty far behind the deployment rates that we're seeing in Northern Europe, China, and some of the other Asia regions in the world. Next slide, thanks. But that being said, we have a pipeline in the U.S. of about 50 gigawatts, not too far away from what's been installed in the whole world over the last 20 plus years. And about half of that, 23 gigawatts, are in this permitting and nearing approval phases. We've seen a few projects start construction this year, as Eric's mentioned, and a few others that have been approved. And there's a list of about 10 or so more projects that are right in the permitting phase and are hopefully going to see approvals in the next couple of years. So the work is coming. Like the work is on the horizon, and the question is how we're actually going to get these projects built. Next slide, thanks. So, part of this is how we lead to this concept of the supply chain, and the ports and vessels that can service it. I think that maybe a few years ago, we had a concept that we could just import what we needed from overseas, that the European suppliers would be able to do the bulk of the work. But as this demand has grown, as our pipeline has grown, and suddenly the Biden administration sets a target of 30 gigawatts installed by 2030, which is about 2,000 wind turbines that we would need in U.S. waters in the next 7 years, and $100 billion or more of investment. This happening in the same time as the context of global demand skyrocketing. It's suddenly that there's too much of a risk of relying on international suppliers. Their order books are full with European projects right now. The vessels are booked, as Eric already mentioned, and honestly, you need a U.S. port. It doesn't even matter where you get the components from. You really need a U.S. port to build these projects efficiently and cost effectively. So we really need to invest in these supply chain resources to be able to have really a commercial scale industry. Next slide, thanks. So, in some of our reports, we talk about some of the challenges to building this industry, and it's certainly a non-trivial investment. There's a risk in these investments because there's still some uncertainty about exactly when these projects are going to get built. Therefore, when do you need the ports? When do you need the vessels? When's the return on my investment for investing in a new manufacturing facility? As technology grows, the turbines getting bigger and bigger, that does impose some significant challenges on the supply chain about how you build a factory that can work for today, but also for 10 years from now. That also includes where you get your supplies from, your raw materials, your subcomponents, your ports, your vessels, your workforce. Can we be cost competitive with imported components? And can we make these decisions to incorporate equity and sustainability in a meaningful way from the beginning of our projects, as opposed to trying to kind of shoehorn these equity or energy justice decisions in a little bit too little too late. Next slide, thanks. And then even just in the last few months, we've seen even more challenges that have kind of come up from these economic headwinds that have caused offshore wind projects to report significant cost increases, and then have tried to either renegotiate or even terminate some of their offtake agreements. So this is some internal work that we've been doing at NREL, where you can track, for example, commodity price rises, inflation, interest rates, other macroeconomic trends. And when you map that to an offshore wind project, you could see potentially a 40% cost increase. These are $1 billion projects. They're very capital intensive. It's a difficult time to finance an offshore wind project right now. But with that being said, I think that something that I think is important to convey is that while this is a challenging economic time, not just for offshore wind, but for really all energy generation technologies, we still feel that there's a long-term cost reduction trend that we expect to see for offshore wind. We're getting better at building these building components. We're more efficient at installing them. Where the technologies and the designs are improving drastically over recent years. So I think that while it's certainly like a challenging climate to make these massive investments in, this is not a reason to completely disregard offshore wind as an industry. This is still a long-term benefit for clean energy, for jobs, for ports on the East Coast, and we need to be able to position ourselves to sort of mitigate or ride through these short-term challenges and sort of to recoup the long-term benefits of offshore wind. Next slide, thanks. So when we talk about investing in this supply chain, and these next few slides will cover a few results from a national supply chain study that we published earlier this year. It's likely that you would need to invest upwards of $20 billion this decade to stand up the first tranche of the supply chain that you would need, inclusive of ports, installation vessels, and manufacturing facilities. That's probably a couple of dozen manufacturing facilities that you need. That's 8 or 9 marshalling ports on the East Coast. That's more floating wind installation ports on the West Coast, and then also some of the key installation infrastructure you need, particularly some of these big vessels that Eric already talked about in the first slide deck. And then to Hadas's point, then there's more investment you need in the O&M facilities, the 20-year investment, the 30-year investment of how you keep these projects active once they've been installed. And so this is a huge investment, of course, but again, that $20 billion investment in the infrastructure could enable hundreds of billions of dollars of offshore wind projects to be installed. And with that, all of the tax revenue and the economic benefits and the jobs and the clean energy production that you can enable with the result of that upfront infrastructure investment. Next slide, please. This is maybe a bit of a busy slide to digest, but we model what you can do in the supply chain based on the number of port and vessel resources that you have. And the short story is that on the figure on the left, if we stopped our investment at the sort of level of vessels and ports that we have right now, more than half of this planned pipeline is going to be delayed into the 2030s. There's just not enough port and vessel resources available right now to build the projects at the rate that we need to build projects to really meaningfully stand up a commercial industry. if you put in an injection of $6 billion this decade, and assuming that you can effectively permit and work with the local communities to make these equitable investments, then we have a shot to have the port and vessels on time to deploy the 30 gigawatts we want to by 2030. And then I think even more importantly, to have those resources in place in the 2030s and the 2040s. I think that there's a lot of interest in this 2030 timeframe, given the Biden administration's announcement on the target. But really, that's a stepping stone to where we want to be in 2050. And we should be thinking about hundreds of gigawatts of offshore wind in the U.S. in the next 30 years, and not just have our blinders on for the 2030 timeframe. This is just the first step. Next slide, please. The standing up a supply chain in the U.S. could be around 10,000 jobs, and those are the jobs that would exist within kind of the big manufacturing facilities, the foundations and the blades and the cables. But I think one of the interesting things that we've been able to look at is that when you consider all of the supporting supply chain, so the people that are processing raw materials, making subassemblies, subcomponents, this is not even including some of the marine logistics and transportation industries as well. There's an opportunity space for 5 times as many jobs as that. And these are jobs that are in small businesses, in that GE nacelle facility in Lynn that may need to be, repurposed for the offshore wind industry. And so I think that it's certainly not trivial to shift your production and your workflow and your capabilities from your existing business to offshore wind. But if you choose to invest in that direction, and particularly if you gain some first mover advantage, there's a big opportunity space for the type of work that could be localized here. Next slide, thanks. And then I think one of the final points that I'll make here is that, and I think this is, I'm sure, not a surprise to anyone here associated with Salem, but a big offshore wind industry or an industrial port is going to impact your port communities, and it's going to impact them in a substantial way. Many port communities in the U.S. are historically disadvantaged, and Hadas ran through some of that context for Salem. Bringing in offshore wind can be a massive benefit or a massive penalty to those communities. There could be jobs, there could be economic benefits, there could be sort of a sense of ownership in the community of being part of this new industry, or you can add pollution, you could add congestion, you could further disadvantage the people that live in that community. So we talk about some of the sort of metrics and indicators of how you need to think about and how you need to work with port communities from the beginning of a planned project to meaningfully design a project like a port development or even the offshore wind work itself in such a way that you're mitigating those adverse effects and ultimately building a more successful project from the beginning. Next slide, thanks. And that's all I'll say today, and I know we're running a bit short on time, but just did again appreciate the time to come in and talk a little bit about some of the supply chain and port pieces.
Thank you, Matt. We've got a few minutes for questions, so I want to make sure we take questions from the audience. Jeff?
Thank you. I'm going to express a concern about Massachusetts. So before I became a counselor, I spent 12 years in the solar business. Until 2015, it was the fastest growing job creator in Massachusetts by far. In 2018, we had the most incentives, the best incentives in the country. By 2018, we don't have any incentives. We lost 35% of the jobs. Commercial solar installers headquartered in Massachusetts don't operate in Massachusetts. They go other places. And my concern about wind, if either you or Eric or Matt could answer this, is that we have this mythical idea that because we have a good port and because Massachusetts has allocated a higher ratio of the portfolio to wind, that's only how much we're going to purchase for the portfolio. But we're getting crushed by New York, Virginia, Maryland, and New Jersey, who are permitting offshore wind at a much higher rate than Massachusetts. So if you guys could address that, because my worry is how fast we can get Salem and other facilities set up.
Now, do you want to take a stab at that in terms of how we ensure longevity for the economic opportunities that we might reap from offshore wind, especially thinking about your last slide, which sounded like you put some thought into how to balance the opportunity while mitigating any potential negative impacts.
Yeah, absolutely. Because I think it's a really valid question, a really, really important one. Because I think that certainly no one wants to see, a fanfare of job creation and then 2 or 3 years later see those jobs go away for one reason or another. I think that maybe there's a couple of points that I'd make to this. One of which is that the gravitational pull of a state-of-the-art offshore wind port, I think, to some extent, supersedes, state boundaries. Like, we just need these ports for offshore wind. As Eric highlighted, there's a limited number of places that you can actually build those on the U.S. East Coast. And so I think whether or not all of the projects that are being serviced out of that port are going to Massachusetts or some combination of other states, Maine, New York, New Jersey, Maryland, whatever it is, I think that the port resource, I think, remains valuable to all of those different states. So I think that's an important one to keep in mind, because that's not something you can just pick up and move to a different location. Second, I think that I would say that part of the I think part of the important thing here is transparency and communication between the states, and understanding that, yes, there's some natural competition between the states for some of the resources and benefits that might come from this. But I think it's also important for all of the states on the East Coast to understand that that no one state is going to get all pieces of the pie. There's more than enough supply chain and investment work to go around. And so I think that being able to understand that, look, there are great local resources in Massachusetts for the following reasons. Therefore, there's a good piece of the supply chain that makes the most sense to build economically in Massachusetts, gives that sort of an efficiency to the market. And then the supply chain, we hope, will evolve in a way that there's limited redundancy between these different regions. So there's always going to be a piece of the supply chain ecosystem which just makes the most sense to build in Massachusetts. And if the states can communicate effectively, work out content sharing rules and the cross-border transactions of this, then the hope would be that that's going to be a sort of a long-term economically viable investment. But I don't want to diminish, I think, the risk that you pose, because this does require a substantial amount of communication and coordination between states, industry, federal government, and so forth. And I think that's a problem which has yet to be fully resolved at this time.
Thanks, Matt. Did you want to add anything to that, Eric?
Sure, I'll just add the size of these components means that this is an inherently local industry. Then you could say, well, then why are we importing everything right now? Well, you can ship all this across the ocean. You still need ports to actually stage. We couldn't be building the Vineyard Wind Farm without the New Bedford Port having been built. So thank goodness we built that when we did. But you can't build more. That port's booked up for the next 7 years. So then how do you actually get to scale? Right now, the problem we have is that there's not enough workforce in Europe or in the world to build the offshore wind farms that we have the appetite for. The question, this is such a hard question because we're doing something so big. What does it mean? And then you work in this way where we have this energy transition and you have a lot of jobs and then you have no jobs. And then you have, all of a sudden you need a lot of people working again. Let's say you train a whole bunch of people up right now. Do they get a job right away? These are exactly the questions that need to be asked. And this is the kind of thinking that needs to happen in order to move the energy transition forward. It is not just this pure magic where all of a sudden, people are trained and they have a job. These things have to be thought about, they have to be understood, and there have to be ways in which people can be trained, and they know that they're going to get a job. And then they know that they're going to be available when the offshore wind needs to construct. And so this is the kind of work that's been done before. I don't think necessarily we've done work at this scale in this part of the country. We've built infrastructure, the bridges and the ports and what's been constructed in this part of the world. We understand it from that. But now we've got manufacturing and infrastructure and maritime all coming together. And so this is something very new. And I think these are the questions. Can a city see itself in the near term being involved in its own local interests, being involved in its regional and state interests? Can it see itself in the long term contributing to the global supply chain? These are questions of, what do we want?
Thank you. I'm sorry, I don't know your name, but yeah.
You started out your presentation talking about the sea installer being here and the person who had the asthma attack and all of that. So can you talk a little bit about mitigating diesel fumes?
Absolutely. So New Bedford was designed with something called shore-to-ship power. And there are stations at the New Bedford terminal where ships can plug in, and they can actually they can run on electricity and shut down their engines during their time at port. So this is something that's happening globally. It's called port electrification. And if you think about mostly, it's about shutting down the diesel generators while you're at port. Now there's work that has to be done by these ships while they're at port. You have to operate extremely heavy cranes. You have to maintain all of this power. And so the question becomes then, what level of power do you bring to the ship? And then there's another question, which is also, how is this regulated and how is this mandated? And so the regulatory aspect, the resource aspect, and then the idea that this becomes the practice of a port. This is happening different parts of the world. It's starting to become a matter of course. You can look up shore-to-ship power and you'll find different ports in the Mediterranean that are already doing this. And I think you'll find that this is very much a reality already in Massachusetts. The question of how do we practice this, how do we make it available, and how do we regulate it, and what are the requirements, what are the rules of the road, that is being hammered out as we speak in New Bedford and will be in Salem as well.
I want to build on Jeff's question. So GE recently announced Niskayuna and Schenectady are going to be building new blade plants and nacelle plants. And I think that's because the New York state legislature, their main focus has been on job creation, whereas our state legislature, the focus has been on savings for the ratepayer. How do we pressure the legislature to start focusing on this? Because, as you've said, I mean, I've worked with Kaz and the IUE on the gear plant. When I saw that announcement about upstate New York, I was as happy as I was for my union brothers up in upstate New York. I'm a little upset that we didn't have a similar announcement in Lynn. What are some actions that we can take to either shift or widen the focus of the state government so that job creation and supply chain is a priority and not just a collateral benefit from this project?
Right. I think that's an essential question. And I think if I'm on the North Shore and I'm thinking about this, I'm not thinking just about my city. I'm thinking about the entire ecosystem. And if you look at Schenectady, there's an amazing tradition there. It's, they have an incredible factory, but between Schenectady and the Hudson River is the Erie Canal, and you cannot ship these nacelles down the Erie Canal. You could only ship the parts at best, and you'd probably rail them to Albany. So the Port of Albany is a big port, but it's a couple 100 miles up the Hudson River. If you look at Lynn, it's right there on the water. So this question about who is negotiating and how are you bringing this to Massachusetts and to the community, it is a question of who and who is talking to whom. And so the question, GE, what is the conversation? And clearly there is a conversation between the state of New York and between GE. And so I think this idea, I come back to the notion of that the towns and the cities are actually very much have an opportunity to chart their own destiny. But if I were doing that work, I would be very interested in having a council of mayors and having a regional presence and understanding, because I think as a region, talking is much more powerful. And if you think about the benefits of Salem that I enumerated during the presentation, putting that argument together, coupling it with this is what we want, and then getting into the question, how are these conversations unfolding? How are these negotiations? How do we bring a plant? How do we, as Kaz always reinforced to me, it's not just one plant. There's a manufacturing workforce in Lynn, which is extremely strong, and there's a lot of manufacturing base. And so I think this idea of having something to talk about, something specific and concrete, getting on the same page and having a message, and then really engaging until you find the people who are in a position to make these decisions. And I think it's the state, I think it's the cities, I think it's the companies, and then I think it's support from the federal government. And I think you have to bring that whole story together in order to be effective. But it feels very possible.
Yeah, and I might just add on to that. I think I really agree.
The ratepayer piece of your question, though, to ask if what will the effect be on the ratepayers once we have offshore wind coming directly into our port, if there will be any positive, negative, no change
in terms of rates?
Yeah.
Well, so that again. The way I think about it is, does anybody remember what you paid for electricity on your last bill? Mm-hmm. What did you pay? Yeah. If you get billed in cents per kilowatt hour, okay? And so you can translate that to dollars per megawatt hour, okay? So when we talk about these big projects, we talk about wholesale prices, we talk about dollars per megawatt hour. When you get your bill, it's in cents per kilowatt hour. If I translate one of my most recent electricity bills to dollars per megawatt hour, that's what I pay retail for generation and transmission, okay? I'm paying over $300 some per megawatt hour. If you look at the wholesale cost of power right now on that app I just showed you, it's like $30 per megawatt hour. So what's going on in between all of this? Right now it's $25 a megawatt hour, okay? But this 320 some odd dollars a megawatt hour that we pay in this region, we have the most expensive electricity in the country. And that's because we're at the end of all these pipelines. And that's what our decision makers were saying also when we started procuring this. Initially, above $200 a megawatt hour, Block Island, $187 a megawatt hour. These would be like the wholesale prices. Those are very high prices compared to the 30 that you see. If you follow that app, on September 6th, I logged in, there was a moment when wholesale prices were $460 a megawatt hour. So electricity prices are anything but stable, all right? And in this part of the world, they fluctuate a lot. And so I think this question about what is the price going to be, it's already very expensive, and the differentials that we're talking about in terms of procurement are relatively small compared to the size of the bill that I pay. And so I think that, again, this question about, well, where is the money? How are we spending it? How does it affect me? You have to just dig a little bit below the surface and kind of look at it and understand what parts of the bill are being affected. So I think that, we are talking, offshore wind is more expensive than land-based wind, but every time we build a turbine in this part of the world on the land, there's a lawsuit and we shut it down and we tear it down eventually. If we build these things offshore, there's a better resource, they're more efficient, they have the potential to last a lot longer, they have the potential to serve us better, and the single biggest cost factor in all of this is whether there's a market or not. And so that's the other thing people get caught up in is like, oh, it's expensive. Well, yeah, come up with anything that there's not a market and a supply chain for, and you're going to pay more early on. So how do we actually bring the costs down? And so there's a story there. And I would just, encourage people to take a close look at your electricity bill and what do you pay for transmission? What do you pay for generation? And keep track of these things, because this is going to become more and more, like I was mentioning, a language that you hear being talked about. And all of us have the capacity to keep track of it and to understand what we think about it.
Yeah, you actually began to address it, but I wondered what you think the factors are that GE will consider when they decide where they're going to put parts and where they're going to manufacture them. What are the things that might lead them to do it in Lynn or otherwise? And practically, you've said it's close, the proximity makes a difference. Are there other financial or political things that you think they will consider when they're making that kind of decision?
Those are very good questions. I have no internal insight into GE. Again, the extent of my knowledge is what's publicly available. I can see where the plant is. I can see the bridges. I can see the canals. And then I think beyond that, these are very interesting questions that I think have to be taken up by people who are in a position to really answer them. And so I would say the question here is, what is the conversation with GE? What does a conversation between Massachusetts and GE look like? And I have the same question you do. And so I think that these are important things to ask not only of GE, but of all of the manufacturing capacity in this part of the world. What is its role in this industry, and how does one find out more about it?
Thanks.
I think there were a couple other hands.
Just a sort of a quick question to follow up on your discussion with respect to the power needs for the vessels and the plugging in. That's been sort of a magic wand that we've heard a number of times about, the diesel fumes and impacts associated with those vessels are going to be diminished by virtue of that ability to plug in. And then when we did go down to New Bedford and went to that site visit and saw them unloading and asked, they said no, their engines are still going, and then because they need the power, and New Bedford doesn't have any intent to provide that power in the future. They don't see that it's realistic. So how realistic is it for us, really, to think about this in terms of being able to control those diesel fumes? As part of your thought experiment, have you thought a little bit about as this technology is changing and the demands are changing? We have essentially an opportunity right now, a clean slate, to do some things and make sure that they happen, or at least envision that they could happen, if that's going to be a promise to our impacted communities in that area with respect to air quality. So could you speak to a little bit more to that, the potential or the reality of that happening? Absolutely.
And you're right. New Bedford currently does not have a practice of plugging in every ship that comes in. And that's why this question of, well, what are the regulations and what are the requirements? This is a part of that conversation. So there is definitely a regulatory aspect to this in terms of how does the port wish to conduct itself. Port electrification is a reality worldwide. It is happening. There are investments being made. There are American investments being made in ports. A lot of them are not offshore wind ports. There is shore-to-ship power available in New Bedford. The question is do we have enough? Why aren't we using it more? These are questions that are ongoing, that are being discussed and debated, in the Mass CEC. And at the same time, just staging a wind farm this size is an overwhelming task. And I think people are kind of in the moment right now saying, I'm just happy that we're actually doing this, and we made it through the hurricane barrier, and we're actually building the wind farm, right? And so we're in the middle of building these really multi-billion-dollar projects as well. And so I think the question of what do you do with the diesel fumes is a question. What are you going to do with the diesel fumes? What are you going to do with shore to ship power? How are you going to bring this to the port? What do you need for resources? And to understand the problem at an engineering level and to scope it out, it doesn't mean it has to be this esoteric thing that only engineers can understand, but it means, what are the ships, the vessel owners, what would cause them to want to run their ship? What would motivate them to plug in? And what are the parameters? And the fact that you all have New Bedford right here in the same state to visit, to ask questions of, that's where I would begin. And so, in my opinion, this whole thing is realistic if we decide to do it, and it's completely unrealistic if we don't decide to do it. But these are not things that happen by themselves. And I think for a long time, people kind of thought, certain things will just happen by themselves. This is, whatever it is that we're talking about doing, this energy transition, averting the climate crisis, creating jobs, realizing our ideals of social and environmental justice, will happen if we do it, and will not happen if we don't do it. And so the question becomes then, what do you need to do to be able to make those decisions, and how do you have a seat at the table? It's very, very serious, gigantic projects we're talking about. It can feel overwhelming as an individual to wonder about these things. But when people make a decision and they get traction over time, they make progress. They make progress over time. And I think that's kind of this issue of thinking long term and saying, okay, I've never heard, investing in the stock market, I've never heard anybody advise you to say, when you start to freak out, sell all your stocks or buy all your stocks. People always say, this is a long term question. I think we're in the middle of a long term decision making.
Well, I would just like to follow it up then with the support for the comment that Matt Shields made in his presentation, where he talked about issues of equity and sustainability being built in at the beginning and not at the end. So these kinds of issues about port electrification, these have to be thought about now.
That's right.
They can't be a part of a conversation after this has all happened. It's a great project, but if we don't start talking about these things now, we've lost that opportunity that you all have given us a great insight here this evening, but you're not telling us anything a lot of us don't already know about what we'd like to see built into this process. So we're encouraged that's the experience that others are sharing as well. So thank you.
One more question? Yeah. Well, my understanding of the port electrification is that the ships have to have compatible systems to be able to plug in. On the West Coast, around the Pacific, they've decided on regulations about that. So in California and Alaska, and I think the state of Washington, they actually can receive ships from around the Pacific Basin because they have agreed on something. Here, we're waiting for the EU to make those decisions. We have not, but we have to be able to have a compatible system so that the ships can actually plug in. So I don't know how they made the decision of what they put in New Bedford. I hope it turns out to be the right one.
Well, and I think your point is well made. You're part of a system, and the question of interoperability and modularity of that system is critical. That'll come up again when it comes to the offshore wind turbines themselves, when it comes to transmission, when it comes to all of these things. And this is why it's so important to understand how whatever it is that I'm interested in relates to these other things. So I think whatever happened, inside of these systems doesn't happen overnight. And if you think about it as an infrastructure question, and you think about it as it begins with, well, what do we want, and how is this being advanced, and where are the decisions being made? These are the things that SAFE is very sophisticated in terms of thinking about these things. And I think that there's kind of this question of, do we want something reasonable? My opinion is it's entirely reasonable to want to build a port of the future that is an exemplar, that is low pollution, that is electrified. The question, how do we get that? What does that mean in the near term? How does that happen? Do we make sure that the conduits are built in early stage, and then do we bring that in later? How is that paid for? Do we actually go to the feds for money? Is that something that happens in the context of the projects? How does that happen? How can SAFE and how can Salem help create a project that does this? And so I think that posture is sort of, the right posture in the sense of like, this is what we want. What can we do to help? How are we going to make this happen? And how are we going to bring this home to our city? And I think that's where you all are. And I think you're in the midst of it. And I think it's very powerful when communities come together and do this. And so this is one of the reasons I wanted to be here tonight with you all, was just to sort of encourage you and to say, I'm a big admirer of what you all are doing up here, and I think that you're asking the right questions.
That's a great way to end it. Thank you, Eric. And I think we'll have more opportunities for discussion in the lobby area.
I just appreciate everyone coming out here. I feel like this is a room full of people that I pester all the time. So I'm glad that you could all be here with us today to really get into these nitty gritty questions. And both Eric, Matt, and Hadas now, I dragged her in very last minute. She's becoming a safe friend, have all made themselves available to you. So I hope I'm not unleashing tons of emails your way, but they want to be a resource to folks in Salem. So do reach out with your questions, and particularly when it comes to our city folks or elected officials, like they want to talk to you, right? They have some resources to support. I realize I didn't even introduce myself. I am Bonnie Bain. I am the program manager for Offshore Wind at Salem Alliance for the Environment. And I know everyone here knows SAFE, but I just, for recording purposes, I'm gonna talk about who we are. So we were founded over 20 years ago around shutting down the coal plant. And here we are today looking at a transition at our port that we've been envisioning for a long time. And we've been longtime supporters of offshore wind, and we're very excited to see it here. And to truly see a just transition is hard work, as we've seen tonight. So I'm grateful to all of you for your dedication to that as we sort of build the road as we go. Thanks for being here tonight.